No. Boom. All right. Excuse me. Let's see. Stacks. What's that do? Doesn't say anything. Oh, there's a lot of delay. I know. So stop trying. Okay. On parent package. Wonder why I have to do this every once in a while. Yep. Oh, almost there. All right, here we go. Climb the hill, kind of instead of receive a distress signal. Out of order. Need to reorder. This says pairs of packets. Pairs are separated by a blank line. How many pairs of packets are in the right order? Okay. Each list starts with, and then zero more. Yep. Each packet is always a list and appears on its own line. When comparing, the first value is called left and the second right. Then. Okay. Which of the pairs in the example are in the right order? So these are the pairs, and those are the rules. Okay, so I have to get the indices, determine some of the indices of those pairs. Okay. How big is our puzzle input? Quite. Okay. Okay. 4L in lines. No. Okay, cool. Okay, so it says they are always lists. Okay. Let's get first value. Okay, let's go on left and right just to make it easier. Okay. When comparing two values, okay, let's call this left, call this right. Oh, right. Yep. Int. Type. Is that ever true? That's true. Okay. 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 If okay. The values if the left is lower than the right integer, then the right order. Continue checking the next part. Okay, so yeah. Yep, and yep. Another one, same integer. Continue checking the next part of the input. This is one of those times. Now test is in order. So, is in order. Move on. Two. On to true, non-equals true. Why would I ever return that? Oh man, I thought I was gonna nail it today. Okay. Okay, so what else do we need to take into account? If both values are lists, if L, no, if right is less than L, we'll return false. If the left integer is lower than the right integer, then the right left is higher. Yeah. And the inputs are the same integer. Okay, if the both values are a list, compare the first value of each list and the second value, and so on. If type of L equals type of R equals list. If the left list runs out of items first, compare the first value of each list and the second value, and so on. Okay. If the left runs out first, no, the right runs out first, then the items are in the right order. Okay. So our default should be to return true. We only want to keep going. We care about the right one. So if that runs out, then yeah. Okay, let's stick with that for a sec. If the right list runs out of in the or not in the right order. Compare to the first and so on. Okay. Okay, so if the left runs out first, they're in the right order. No, that should still be false, but so left runs out first. Well, they run out first, but the first comparison should be false. 2 and 2, 3. Okay, we go for length of left. Yeah, that should be true. Yeah. Right? The left runs out first. Right order. Okay. Unless they're the same length and no comparison, make the decision about the order. Continue checking the next part of the input. If exactly one value is an integer, convert. If exactly one value is an integer. Okay. So if they're not the same, yeah. What's it supposed to do? 13. Oh, the sum of the indices. Okay. Yeah, so add I. Just part 8. Okay. Yeah. Okay. Yeah. Okay, it's supposed to give 13. 13. Yeah, we're pretty far from that, aren't we? Yeah. Okay. Oh. No. Okay. Print. Left. Right. Okay, pair 1. So they are in the right order. That's what we got. Second one, in the right order. Third, not in the right order. Right. Four. 1, 2, 3, 4. In order. 5. Not in the right order. 1, 2, 3, 4, 5. Yeah. Right side ran out of items. Oh. Okay. Yes, no, no, yes, no. Yes. Oh. Compare. Yeah, compare 1 versus 1. Then we convert this one to compare to left side is smaller. Oh, so they're in the right order. Okay. Yeah, I'm a little bothered by it, I have to admit. I thought this was going to be easy. Okay, so we have those. Compare 1 and 1, 1 and 1, 3 and 5. Left is smaller. Oh, so we stop there? If both values are integers, the lower integer, if the left is lower, they're in the right order. If 27. So this one's in order. Yes, yes, no, yes, no. Yes, yes, no, yes, no. Okay, so far so good. Yes, no, yes, no, no. Yes, no, no. Yes, no, no. One, two, four, and six. Zero and order 3. Ah! Is it 1? Yeah. Yeah. Cool. Really? Huh. That's really annoying. Okay. All right. Fair enough. First one will come left and the second will come right. Both values enter. Lower integers should come first. If they are if they're different, then we turn and then we return our in. That better? That looks more likely. No. Okay. Okay. Okay, so all right, so we have left and right, 1 1 3 1 1 and 1 1 5 1 1. Yep. Oh. That's the same as before, right? Think so. Yeah. Okay. So if they're the same, that right? If they're the same, we continue to the next one. Lower, if the left's lower, if the left's higher. Not in the right order. They're the same. Continue checking next part. Okay. If they are both lists, compare the first value of each list and the second value. If the are in order. Yeah. Okay. Okay, so that's 1, 1, 3. Okay. Yep. Then we have 1. Yeah. So on the left, we have. All right, so they're both. That might not yield a result. Okay. If in order. If they're not in order, then we're going false. But what if we don't know? None. If in order is none. No, it is not none. Return in order. Else we continue. Yeah, let's try that. Yeah, that's a new number. Let's try that. Okay. Okay, they're both lists. What? Oh, right, because we go back into this one, I guess. So they are the same. We continue. That was it. And then we return none. If it's not none, right? Compare that. That's 1. Okay, so then we end up comparing 2, 3, 4 versus 4. So they're not the same type. Why did it jump up there? Okay, so we have 2, 3, 4, and 4. 2, 3, 4, and 4. Yeah. They're not different. So we turn R into, and then we check if they are in order. Right order. Okay. So now we have 9 and 8, 7, 6. So they are not in order. We compare it. Okay, then we have 4, 4, 4, 4. Okay. So LNR, 4 and 4. Oh, both lists. Indeterminate. Okay. But it is none. Okay, so. Okay. So L is 4 and R is 4. We're the same. We continue. Yep. Good. That's a new number again. Okay. They both integers. Yep. And they're okay. Why? What? The left runs out of items first. Wait 2 minutes. That's lame. Oh, I haven't even tried my tests in a while. They still pass. Okay. Okay, I mean, I can use all of these. But this really does all of that for me. Hmm. Is that what I think it is now? Yep. Still 48 seconds. 5 seconds. Right. All packets in the right order, disregard blank lines. The distress signal also requires to include 2 additional divider packets. Okay. Organize all packets, the ones in your list of received into the correct order. Oh, okay. You include 2 divider pack. Okay, locate them. You find the decode for this. You need the indices. Probably multiply them. Yeah. Okay. Yep. So, yep. And then we want to LMs, no, sorted, key. No, okay. Customize the sort order. No. There's got to be a way to just give it a comparer. Key is a function to execute to decide the order. Sorted key. on each list element, but I don't want it to unlist. I want to compare them. Damn it. Complex sorts. Well, two records will retain the original order. And the sort is sorted by the grade. Ah. Oh, okay. No, not from meter tools, is it? Func tools. Are in order? No. I don't even remember what I'm doing here. Okay, so 2, was it 6? 2 and 6. Return ordered. Okay, ordered index multiplied by probably need to add 1 to each of these. For the sample, let's see 140. No way. "45 minutes. All right. Let's see. There was a lot of nonsense here. I really wonder how that thing works, though. Into a key function. It's not an object. Yeah, cool. That's neat. Yeah, that wasn't too bad. I mean, I had a lot of stumbles for sure, but by and large, it wasn't too bad. I might as well just do the recap straight away. Yeah, sure, why not? Okie doke. Here we go. All right. Okay. All right. Day 13. Distress signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, which is your puzzle input, to decode the message. Your list consists of pairs of packets. Pairs are separated by a blank line. You need to identify how many pairs of packets are in the right order. And then we have a whole bunch of pairs of packets here. Okay. Packet data consists of lists and integers. Each list starts with an open bracket, ends with close bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. And then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. If both values are a list, compare the first value of each list, then the second value, and so on and so on. If the left list runs out of items first, they're in the right order. If the right does, then we're not in the right order. If they're the same length and no comparison makes a decision about the order, continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value. Then retry the comparison. For example, if comparing a list with three zeros and the single integer 2, convert the right value to a list containing 2, and the result is then found by instead comparing the list of zeros and 2. Using these rules, you can determine which of the pairs in the example are in the right order. And yeah, then we go through each of the pairs. We have these two where we compare 1 and 1, 1 and 1, and then we get to 3 and 5, and finally we can determine that the left side is smaller, so they are in the right order. Pair number 2, start by comparing these. They're the same. Then we compare these. And so first we turn this one into a list, and then we retry. And we determine that 2 is lower than 4, so they are in the right order. Then we have 9 versus a list with a list of 876, and 9 is, so we convert 9 to a list, try again, and then we find that left side is smaller. No, left side is greater than, so they are not in the right order. There's a whole bunch of 4s. Left side runs out of items first, so they're in the right order, and so on and so on and so on and so on. Okay, so what are the indices of the pairs that are already in the right order? The first pair has index 1, the second has index 2, and so on. Okay, so they are 1 indexed. That's good to know. In the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of these indices is 13. Yeah, and I once again struggled to read. So it took me a long time to get all these different rules into the code. So I think maybe if we look at, I'm going to get rid of that, and then we're going to do this. Cool. Okay. So to implement all these different rules there, I create a function called RInOrder. It says that they're always lists, so we compare the lists, compare them as lists. So we have a variable I, which index we use as the index into the two lists. And if the left side has run out, then we're good. Then we say yes, according to this rule right here. If the left side runs out first, let's see if we can make this a little smaller. Hope you can still read it. Okay, if the right side runs out, then we return false. Yep, if the right list runs out of items first, then they're not in the right order. Okay, so once we've determined that we are not past the end of either of them, we get the value left and right. If they are both integers, then if the right is less than left, then it's false, and vice versa. That's the rule we have right here. If the left integer is higher, then they are not in the right order, and so on and so on. All right. If instead they are both lists, then we just recursively call this function RInOrder, and we store that value. And if we get to the end of an array, or sorry, a list, and we haven't yet determined which one is the winner, we return none. I'm basically assuming that we will never end up with 2 inputs that are indeterminate. So I assume that all the input that we are provided with has an ordering that is deterministic. Yeah, I guess deterministic. Anyway, yeah, but if we finish looking at one of these nested lists and we don't know which one is the winner, then we just keep going. All right. Finally, if they are not both integers or both lists, then we turn whichever one is an integer into a list. And we do the same thing. We try to see if we can determine the ordering. If we cannot, then we follow through, and then we go, then this for loop goes on to the next one. And if we can determine the ordering, then we return whether it's in order or not. So, yep. So part A really becomes just loading all the lines. We set a counter. Then I use this here to jump 3 lines at a time. And then I have the left and the right. I just use the Python eval function because this just happens to be how Python would represent these exact values. So it's just a matter of interpreting this as though it were Python. So that gives me left and right. And if they are in order, I increment the counter by, so it is the I value gives us the line number, but we need the counter tracks the pairs. So all these two here are pair number 1, and these two are pair number 2, etc., etc. So I will be 0 at first. So I take I divided by 3 plus 1. That gives me 1. And on the next go, I is going to be 3, and so I take 3 divided by 3 and add 1, and that gives me 2, and so on and so on. So this gives me the index of the pair, and add that to the counter, and that gives me the answer. All right. So, yep, I think that's all there is to say about part A. Part 2. Okay, now you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. So, and they look like this. So double nested 2, double nested 6. So a list of the value 2, and same for 6. So using the same rules as before, organize all the packets. So all the ones that are in the input, as well as these 2 divider ones, and order them according to the rules above. So, yep. And then what we just got to do is we need to find out where 2 and 6 land, and multiply them, and that gives us the answer. So that is what we have over here. Part B. So we look at I make a list of all the different elements. I add the 2 and 6 as per the instructions. Then what do I do then? Right. So I just copied the where is it? There. The for loop from part A. This is stupid. For ln lines. This is better. If L is empty, then we just continue. Otherwise, we add the line. That still gives me the right answer, doesn't it? It doesn't. I shouldn't have done that. Are in order if range left has no line. Oh yeah. Like that. Yep. Yep. Okay. So I skip over the empty lines, and otherwise whatever is there I add to my elements list. Okay. So sorted is a Python function that sorts a list according to, well, by default, it just compares them. But we can't directly, I mean, we can't just Python can't by default just compare these, as we want them to, because there are all these special rules. But the sorted function wants a key. It doesn't want a comparator function. So luckily, we have in functools, there is something called CMP to key, which basically turns a compare function into a key. So I had to create a function that would return -1 if they were in one order and +1 if they were in the other order, and, well, 0 if they're the same. But I didn't have to worry about that because, well, they all have, there is a given order that is correct. So yeah, that gives me the ordered elements. And then it's just a matter of here. So ordered is the ordered lists of all the lines from our input. And then ordered.index 2 is going to give us the index for this, what do they call them? Divider packets. And ordered.index, and the same for 6, is going to give us this one, and then we add 1 to each of them because they're 1 indexed, and multiply them, and boom, that was it. So part B was a lot more straightforward than part A. I come to the same conclusion every day, that I should slow down, I should read all the rules and everything and just implement it as it says, and then I would have gotten there a lot sooner. Slow and steady wins the race, right? But I'm not good at that. Patience is not my strong suit. But yep, that's it. That is day 13. And we're done. All right. If you have any questions or comments, leave them below, like and subscribe, and I'll see you tomorrow.